Okay, guys, so here are your notes for P.6. This is the last section in chapter P. So we're going to be looking at points in the Cartesian plane, using the distance formula, the midpoint formula, and looking at real-life problems. So the words Cartesian plane might not mean a whole lot to you, and that's because in the past it's been called the rectangular coordinate system. And basically, that's what you see right here. That's your rectangular coordinate system with your x and y axes. So vocabulary and notation review. First of all, when we're listing points, we've got x comma y. So your x comes first, your y comes second. Your x-axis is your horizontal axis, and your y-axis is your vertical axis. The point where, oh my goodness, sorry about that, guys. My arm hit it. The point where they meet is called the origin, and it is the point 0, 0. And finally, we've got 4 quadrants. Quadrant 1, quadrant 2, oh my gosh, my arm hit it again. Quadrant 2, quadrant 3, and quadrant 4. And so it's just knowing that in quadrant 1, x and y are both positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x and y are both negative. And in quadrant 4, x is positive and y is negative. So plotting points should be pretty easy for you. Negative 1, 2, we go 1 to the left, 2 up. 3, 4, we go 3 to the right and 4 up. 0, 0, we've already discussed. 3, 0 is going to be on the x-axis. And then negative 2, negative 3, we go 2 to the left and 3 down. So example 2 is sketching a scatter plot. And so it gives us years and subscribers. And the years start with 2001. So what I did was I made a break in our graph. Since it didn't start at year 0, it started at year 1. And then in subscribers, since they were kind of weird numbers, I went in 50s. So we're going to kind of do our best here and eyeball it. You could do a better job on a computer program, and I urge you to do that if you feel the need to. Desmos and GeoGebra are some really good programs you could use. But when we end up doing this, and I'm just going to do it quickly, we end up getting a linear model for this because every year it kind of goes up. So the subscriber pattern follows a linear model. And I know you guys know how to plot points, and it's much easier on your paper, and you can eyeball it, but it ends up following kind of this linear pattern. Okay, the distance formula. So I'm going to show you how we actually get the distance formula. Since I know you know how to use it, we're going to go a little bit farther. So recall the Pythagorean theorem, and that's a squared plus b squared equals c squared. So if I have a right triangle whose hypotenuse I'm going to call D, this right here can be x1, this is going to be x2, this is going to be y2, and this is going to be y1. The distance from here to here which we learned a couple sections ago, is the absolute value of x2 minus x1. Likewise, this is the absolute value of y2 minus y1. So, by the Pythagorean theorem, our hypotenuse squared is equal to our leg squared plus our other leg squared. When we get d by itself, we take the square root. And since it's distance, we're only interested in the positive answer. So we get d equals the square root of the absolute value of x2 minus x1 squared plus y2 minus y1 squared. Now, your exponent rules state that this and this are just x2 minus x1 squared plus y2 minus y1 squared. That because since they're squared, they're going to be positive either way. So that is your distance formula and how it's derived. So we're going to find the distance between the 2 points. I'll do A and then you can try B. So 3 minus negative 2 quantity squared plus 4 minus 1 quantity squared. That gives me 5 squared plus 3 squared, which is the square root of 25 plus 9, which is the square root of 34. And I cannot break down 34 at all, so if it doesn't ask me to round, that's my answer. Now, if it did ask me to round, it would be about 5.83. So you guys go ahead and try B. And then when you're done, you should get the square root of 37 as your answer. Okay, verifying a right triangle. So show that the points 2, 1, 4, 0, and 5, 7 are the vertices of a right triangle. So to do that, a squared plus b squared equals c squared should check out. So if we find the distance plus the distance equals the distance of the hypotenuse, and we can check that, then we should be good. So if I graph it just for a visual, 2, 1, and let's say that's A, 4, 0, and that could be B, and then 5, 7, that could be C. We need to verify that. So we're going to need to find the distance from A to B, the distance from A to C, and the distance from B to C. So AB would be between 2, 1 and 4, 0. So it would be the square root of 4 minus 2 squared plus 0 minus 1 squared, which would be the square root of 5. AC would be between 2, 1 and 5, 7. So that would be the square root of 5 minus 2 squared plus 7 minus 1 squared, which is the square root of 45. Finally, BC would be 4, 0 and 5, 7, So we've got 5 minus 4 squared plus 7 minus 0 squared, and that's the square root of 50. So we've got a leg, and a hypotenuse. So our question is the square root of 5 squared plus the square root of 45 squared equal to the square root of 50 squared? And it is, because 5 plus 45 is equal to 50. So you guys try this one. Okay, the midpoint formula. Remember, if we have 2 points, x1, y1, and x2, y2, the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. It's like we're averaging the x values and averaging the y values. So, negative 5 plus 9 divided by 2, negative 3 plus 3 divided by 2. This is 4 divided by 2, which is 2, and 0 divided by 2, which is 0. In part B, we've got negative 2 plus 4 divided by 2, and 8 plus negative 10 divided by 2. So we've got, this is 2 divided by 2, which is 1, and negative 2 divided by 2, which is negative 1. All right, so example 6, finding the length of a pass. A football quarterback throws a pass from the 28-yard line, 40 yards from the sideline. A wide receiver catches the pass on the 5-yard line, 20 yards from the same sideline. How long is the pass? So, we can use the distance formula for this. And it doesn't matter if you do 28, 40, and 520, or 40, 28, and 25. As long as you're consistent. You make the yard line number the x value or the y value, and then you make the yards from the sideline number the other value. Okay? So it doesn't matter as long as you're consistent. So the distance is the square root of 40 minus 20 squared plus 28 minus 5 squared, which is the square root of 225 plus 484. No, that's not right. That's the next problem, my bad. Which is the square root of 400 plus 529. That's the square root of 929. Since it is football, square root of 929 doesn't really mean much to me. So I'm going to say that's about a 30-yard pass. And still not knowing much about football, that doesn't mean much to me. So maybe if someone could tell me if that's a good pass or not after you watch the video, that'd be great. Because I don't know if that's a good pass or not. So let me know. You guys can go ahead and try this, because I know you know how to use the distance formula. You don't really need to listen to me talk about it some more. Example 7, estimating annual sales. So Starbucks Corporation had an annual sales of approximately $9.8 billion in 2009 and $11.7 billion in 2011. Without knowing any additional information, what would you estimate in the 2010 sales to have been? So, what I noticed is that 2010 is right in the middle of 2009 and 2011. So, if we would have averaged 2011, we would have, in 2009, we would have gotten 2010. Kind of like our midpoint formula. So, if I average the 9.8 billion and the 11.7 billion, with the information I'm given, I should get the approximate answer that I'm looking for. So 9.8 plus 11.7 divided by 2 would be about $10.75 billion in 2010. Now, we're assuming a lot of things with that. Again, they said without knowing any additional information. So I just want to say that's assuming this is linear, because the midpoint formula is to find a midpoint of a line segment. So I'm assuming from 2009, within 3 years, Starbucks, especially something like Starbucks that has gotten so much publicity and just business over the years, that their revenue does not increase linearly, right? It's probably going to increase more, maybe not exponentially, but faster than just a constant rate. Okay? So you try the Yahoo Incorporated. So pause me if you'd like to try that. And then finally, we're translating points in a plane. So I'm not going to make you actually do it and graph it, but I'm asking you, what are the new vertices if the triangle is translated 3 units to the right and 2 units down? Write the translation in correct geometric form. By that I mean, remember when we were to the right, we would do x plus 3, and we were down, we would do y minus 2. And so then it's very obvious, to every x value I add 3, and to every y value I subtract 2. So -1 plus 3 is 2. 2 minus 2 is 0. 1 plus 3 is 4. -4 minus 2 is -6. 2 plus 3 is 5. 3 minus 2 is 1. So this was something you learned in geometry that they just stuck in here for funsies. So now you should be good to do your P.6 homework. It shouldn't be that hard. This was probably the easiest lesson out of the bunch. So next time I see you, we will be